right, so I'm doing a solution here to problem 124 on homework 6E. So it says, as shown below, the coefficient of kinetic friction between the surface and the larger block is 0.2. So I'm guessing this is the larger block. And the coefficient of friction between these is 0.2. So coefficient of friction, let's see, I'll call this block 1. So this will be block 1. This will be block 2. So coefficient of friction for block 1 is 0.2. And then and the coefficient of kinetic friction between the surface and the smaller block is 0.3. So coefficient of kinetic friction of this is 0.3. If F equals 10, so this is F, so F equals 10 newtons, and M, so capital M is 1 kilogram, so that means then, so we could basically say, so if M is 1 kilogram, then M1 is equal to 2 kilograms, and M2 is equal to 1 kilogram. All right. So we got all that. So what is the tension connecting these ropes? What's that tension force right there? Let's see. So I'm thinking, so I know this is a rigid object, so the first thing I'm going to try and do is try to calculate what the acceleration of this system is. Once I got the acceleration of the system, I can assume that they're all the same, and then I'll do some object switching to try and figure out what the tension force is. That's going to be my plan of attack. Let's see if it works. Let's see how it works out for me. So here we go. I'm going to call all of this my system, like this. So this is everything is the system. That's everything is the system. And I want to be careful here. So the force is acting here. I think I'm going to, let's see how this works. Let's see how this works. So I think I'm going to, oftentimes I'll combine the masses and say, oh, it's all one normal force. It's fine, you know, type of thing. But I think it's going to be better to show the separate normal forces, I think. Let's see how this works. So, yeah, what the heck? Let's just. Or do I want to combine them? I might want to combine them. Yeah, let's combine them. Let's combine them. So this is all, so there's a normal force here and a normal force here. And what I'm going to do is combine these normal forces so that it's all one normal force Fn. I might regret this, but we'll see. And then the weight, this is now the total weight of all this. So the weight, this is the total weight of everything. So this is going to be 3 mg, right? So there's that. And now, careful, there's two friction forces really here. I could say that's a total friction force, but each surface has its own coefficient of friction. So I'm going to say instead there's a friction force 1. I'll just call it, yeah, let's see, I want to try and simplify things. So we'll say FF. I'm not going to do the K. So, and then the friction force 2. Friction force 2, I think, is going to be more, maybe? I don't know. Let's just do this. And then there's a total, so if the whole thing's my system, then there's the total force F doing this, right? All right, so let's see where this gets me. So if I do F net equal, those are the external forces acting there. There's no tension force because that gets canceled out because I made the whole thing my system. So I think though I'm going to need to, let's see, so we got F net equals MA. F net in this case is going to be, you've got in the x direction, you've got the applied for, this is called F, sorry. So you got F, which I know is 10 newtons, minus force of friction 1 minus force of friction 2 is equal to the mass times the acceleration, and I'm trying to find out the acceleration. And so let's see, I know this is 10 newtons, so I got this. I don't know this, but I do know the total mass. So let's see, this is the force minus FF1 minus FF2 equals the total mass, which is 3m, right? 3m times the acceleration. So then I'm going to divide all this by 3m. So this is going to be f minus ff1 minus ff2 over 3m equals the acceleration. So I know this and I know this. So if I can find these, I got this thing. And here's where the issue now comes in where, oh, darn, you know, it's all a wash here. I'm not going to be able to find out because in order to, I got the coefficient of frictions. So in order to find out what the friction force is, it's going to be the coefficient of friction multiplied by the normal force for any one of these. So, so what I'm going to do, and hopefully this isn't too confusing, I want to be as rigid as I possibly can, though. I want to be as rigid as I possibly can. So I could do some shortcuts and stuff. So, but I want to be super careful. So, and it is going to take me longer in being super careful. I'm sorry. Oops, sorry. This is mu k times the normal force. So I know mu k. I got that. So if I can just get the normal force, then I'll have this. Okay. So let's see. All right. So I'll do on a separate occasion here. So I'll do off over here. I'm going to make, this is block M, this is M1. And then let's start there. M1. So now this is if M1 was my object. So if M1 was my object, what would a free body diagram look like? It would be, let's see, it would be the normal force. I'll call this Fn1. And then down here would be 2mg. That's the weight. You got the friction force. That's Ff1. And then you've got the tension force, Ft, which is what I'm looking for. No, that's not going to. Okay. So, all right. Let's see. And really, all I really want to care about is this, because that's going to get me the normal forces here. So let's just do that. So we're going to do F net equals ma. So this is going to be in the vertical direction. So that's going to be the normal force 1 minus 2mg equals, and then the acceleration in the vertical direction is going to be 0. So that's just going to be 0. So Fn1 equals 2mg. This should be a big M, because that's kind of what they did there. And so that's what I'm going to plug in here. So that now for object 1, so for force of friction 1, it's going to be mu k1 multiplied by 2mg. Questions so far of what I'm doing? Nope. Just keep going, you dope. All right. So next up, I'm going to do the same thing, but now for M2. So this one, I'm doing now. Let's do this. So now this is my object for M2. So for M2, I would have, this one's going to be fun. This one's going to be normal force 2 pointing up. You got mg pointing down. You've got that force F pointing to the right. And then you got a friction force, FF2, I called it. But you've also got the tension force, which is what we're trying to find. But once again, all I care about is what's happening in the vertical direction. So again, I'm going to do F net equals ma. And this is all in the vertical direction. So it's going to be Fn2 minus mg equals, again, the acceleration is going to be 0. So Fn2 is going to equal mg like that. And now I'm going to take this, and again, I'm going to plug it. How would I do this? Boom, that's going to go in there. And so for Ff2, it's going to be mu k2 multiplied by capital Mg. So hopefully we're okay with how I got those. I had to, so this is, again, this is object switching, and this is object switching like we've never seen before. This is, yeah. So, okay. So now that I got all that, now I can plug those all in here. So I got everything here. So now I can take all this, take this, plug it in there, take this, plug it in there, and I'll get the acceleration. Let's do it. So I got the force minus mu k1 2mg minus mu k2 mg equals the acceleration all over m. All right, now I just need to plug in stuff. So this is 10, I think, is what they said. Mu k1 is 0.2 multiplied by 2 times the mass, which is 1. Oh, that's nice. Times 10 minus mu k2. Sorry, mu k2. Times, so it's 0.3 times the mass, which is 1. That's nice and convenient. So this is all over 1. Times 10 again. All right. So all this over 1. So let's see, I could factor out a 10 out of here. So let's do 10. And then this is 1 minus 0.2 times 2 minus 0.3. So what's this come out to? 1 minus 0.4 minus 0. Wait, 2 times 0.2 is 0.4, I think. Let me know if my arithmetic's wrong. So I get 0.4, negative 0.4 minus 0.3 is negative 0.7. So 1, all this multiplied by 10 equals the acceleration, equals the acceleration. So, oh, okay, yep. Oh, okay. I'm trying to do all this just kind of, yep, yeah, exactly. I'm trying to do this without using, getting crazy calculator. So this is 0.7. So I think it's going to be 0.3 times 10 is the acceleration. So 10 times 0.3 is the acceleration. So this is going to be 3 meters per second squared is my acceleration. And now that I got that, it's all downhill from here, I think. Because now that I got the acceleration, I know that that's the acceleration of the whole system. And so now, this was with everything. So this was with everything is my system here, right? But now I want it to, what happens though if I want just to get the tension, because the tension force got eliminated in there. I'm going to say my easiest way to do this is use this to find out what the tension force is. I think that's going to be the easiest way to do it. And lo and behold, I already did it over here. So now I'm just going to apply F net equals ma just in the x direction over here using this. I think this is going to work. So Ft minus FF1. So we got Ft, that's what I'm trying to find, minus the force of friction 1 is equal to the mass, that's 2m. That was the 2m one, right? That was m1? Yeah. So it's 2m times the acceleration, which I now know. So the tension force is going to be, minus FF1, we found out back here is mu k1 times 2mg. So this is mu k1 times 2mg equals 2ma. So now just isolate the tension force. Factor out the 2m for an easier calculation. Units work out, that'll be fine. So let's see if we can plug this in. So we know mass, we know m is 1. The acceleration we found was 3 meters per second squared. Coefficient of kinetic 0.2 times 10. So this is going to be a tension force of 2 times 3 plus 2 So that's 5 times 2 is 10. So the tension force is 10 newtons. I hope I did that right. Is that the answer? I don't... shoot. All right. Maybe I made an error somewhere. And of course I'm recording this. So let's see. So, okay, here we go. So, yes, I made a mistake with this video. Is that all of this actually just simplifies. So this actually all simplifies. So all this ends up simplifying to 1 meter per second squared, not 3 meters per second squared, like I said. Which would mean that changes the acceleration here. This is now 1. This is 1. So I got 1 plus 2 times 2. So it's 3 times 2, which is 6 newtons. So there we go. Sorry about that error. Okay, hopefully that works out. Bye.